Welcome to Internet Quality Academy. The channel is for the quality control engineer, site engineer, and the civil engineer who are working in the construction field. In this channel, we are dealing with anything and everything which is required to get success in the construction. Today also I'm going to discuss about a very important topics on the concrete, that is chloride attack on concrete. So chloride ion is present in the water, in the atmosphere, or in the soil. So whenever this chloride ion is entering or penetrating inside the concrete, what is happening, why it is harmful, and what is the best practice, and what is the IS code recommendation. I will discuss each and everything in details in this video, chloride attack on concrete. So stay tuned until then to get the full information. And if you are new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subject. So concrete is the main backbone or main pillar of any projects. Nowadays, we cannot even think a project without the concrete. Now, it is our duty to produce a good concrete, and also it is our duty to make that concrete longer and as per the service life so that it's more durable. So one part is the producing the concrete, another part is the maintaining the concrete. So one is the harmful ion that is also affecting the durability and the strength, that is chloride. So chloride ion, where it is there in the atmosphere, in the groundwater, in the soil, and also whatever the water we are using for preparation of the concrete, that water also containing the chloride ion. So this chloride ion is available inside the concrete. So if it is reacting with the concrete, that is the detrimental effect. So first we need to know what is chloride attack. Chloride attack on concrete primarily occurs when chloride ions, typically from de-icing, salts, seawater, or other environmental sources, penetrate the concrete and reach to the embedded steel reinforcement, leading to the corrosion of steel. So what is happening? The chloride ion is there in the atmosphere or in the soil, but it can penetrate inside the concrete. How? If the concrete is porous, is more permeable, and if there is a crack or any weak spot is there, so this will penetrate inside the concrete, and if it is reached to the steel, it will start corrosion of the steel. This is the chloride attack on the concrete. The next is what the chemical reaction is happening whenever the chloride ion penetrate inside the concrete. So when chloride ions penetrate the concrete and reach the steel reinforcement, the following reactions can happen. So if you iron and chloride ions, so it will start reacting with the iron in presence of oxygen and water. So again, the water is a paramount factor. Without the water, this chloride ion will not react with the iron of the steel. So it is essential that the water is to be present. So that is why another way we can protect our concrete from the chloride attack, to resist the penetration of the water inside the concrete. So if we can that one, this reaction will not happen. So iron oxide and iron chloride will form. So these chloride ion act as the catalyst, continually adding the corrosion process without being consumed. This reaction between iron, oxygen, and water creates rust, what we call iron hydroxide and oxide, which occupies a larger volume. So how this corrosion process is happening, so I have made a detailed video, step by step, electromagnetic, electrochemical reaction. I explain each and everything in a video. Click in the link or in the description. You will get full information about how the corrosion of steel is happening due to the electrochemical reaction. But now, as of now, this chemical reaction is happening and this rust is forming. And if the rust is forming, it is the more volume. So if the inside of the concrete is more volume, what will happening? The internal stress will generate. So if the instant internal stress is generating, the concrete cracks will happen, and concrete spalling, scaling, everything is happening. So two things is happening here. One, this chemical reaction with this reinforcement, and reinforcement corrosion is happening. So the backbone or the main skeleton, that reinforcement, that is become damaged. So the durability is a problem. And another way, the concrete crack is happening, concrete spalling. The concrete is also itself deteriorating. So in this chemical chloride attack, both the iron and the steel or the concrete is equally damaging. Okay, so what is happening, if the crack is generating, so this crack is again become a weak spot to enter, and again chloride, sulfate, carbon dioxide, each and everything, again these also will react with the concrete, and again the durability will be a problem. So this is the chemical reaction is happening inside the concrete when a chloride ion penetrate inside the concrete in presence of water. This is to be very much remembering that without the water no reaction will happen. So these are the chemical reaction. Now what is happening if this chemical reaction is happening? So why it is harmful? Let it be. But again the steel corrosion, so we already discussed that chloride attack initiate corrosion of steel. So if corrosion is still is happening, this property is become less because the damage. So the mechanical property, the chemical properties of the steel which we design, that property will be changed, and we are not getting that much of tensile strength or the yield stress, whatever. So what is happening? Whatever the design parameter, now it's become deteriorating or decreasing. So that means we are not getting that much of strength, and the durability and the structural stability is a problem. The another way, expansive forces, already I discussed. The expansion of rust within the concrete generate internal stresses that lead to cracking and spalling. So expansive more steel and worsening the concrete. So this internal stress also making the concrete deteriorate. If the concrete crack is there, again there's a weak spot that I already discussed, then reduces the service life. So if the concrete and the steel both is deteriorating, it's damaging, so what will happen? Structural stability will be in a problem and service life will be reduces. Then reduces the durability. What is durability? Durability is nothing but how the concrete is withstand in the environment. So how we are withstanding, how we are protecting ourselves from the environment, that is we also concrete is protecting its properties from the environmental factor, that is the durability. So what is durability and what is the factor affecting durability? I have made a detailed video, link is there or in the description, please check, you will get the full informations. So this durability also become a problem. It's the cracks allow further ingress of water and harmful agent, accelerating the deterioration process. So either way, if it become the deterioration of the concrete and the steel, so that the structural stability is a problem, service life is a problem, durability is a problem, and the strength is a problem. So what we design for the strength and the durability, that we will not get, and our service life, the concrete, will not achieve whatever we are expecting. So that is why this is very much harmful. Now, chloride is there, it can't penetrate inside the concrete. Now, we want to protect our concrete from the chloride attack. So, what will be the remedial measure? There are so many. So, first is use low permeability concrete. Low permeability concrete means it is the permeability is very less. So, there is a less chance of penetrations of chloride ion inside the concrete. If we can do that one, so what will happen? If the chloride ion is cannot penetrate inside the concrete, our steel will not react with the chloride ion and the water, and the rust will not form. So reducing the permeability of concrete can prevent chloride ions from penetrating the concrete. This can be achieving by using lower water cement ratios, supplementary cementitious material like PFM or the pulverized fuel ash, silica fumes, and proper curing practice. So if we want to make low permeability concrete, there are some measures. What is the measure? The lower water cement ratio, supplementary cementitious material, and this proper curing process. The curing process is very much important. Without the curing, this permeability cannot be achieved or the durability cannot be achieved. So that is why you need to protect our concrete and the curing process to be monitored. So what is curing? What is the minimum period and how to do the concrete? I have made a detailed video. Link is there or in the description. Please check. You will get the full information. Then corrosion resistance reinforcement. Now we have the corrosion resistance reinforcement in the market. We can use that one. So it also help to reduces the carbon attacks. Chloride attack. So use the corrosion resistance materials like epoxy coated rebars, galvanized steels, or the stainless steels can help reduce the risk of chloride induced corrosion. So this way, this will not react with the reinforcement. If anyway the chloride ion is penetrating inside the steel, it will not reacting. So if it cannot react, the corrosion all will not happen. So corrosion resistance reinforcement also one way to reduces the chloride attack. Then cathodic protection, there is a very innovative way and widely used that the method where a sacrificial anode like zinc is used to protect the steel from corrosion, reversing the corrosion process. The cathodic protection is the industrial waste we're using. So here it is protecting the our concrete from the corrosion of the steel. Then coating and sealers, the protective coating on the concrete surface such as saliner or silicon based sealers can prevent the ingress of chloride ion. So whatever the method we are proposing, what are the remedial measure we are testing on the way that the less amount of chloride ion can penetrate inside the concrete. So the reaction will be very less and our corrosion or will not happen. Then corrosion inhibitors, it is a very much important and useful, and it's the latest technology that adding corrosion inhibitors to the concrete mix can reduces the corrosion rate even in chloride laden environment. So it is a new technologies and new age technologies that corrosion inhibitors we are penetrate in using inside the concrete. So it is lower the chances of the reinforcement, or it is to prevent the corrosion of the steel. Then proper concrete cover, that this is very much important, that if the concrete cover is proper, so what is happening, if the chloride are also penetrate, it cannot reach to the steel. But during the construction, if we neglecting the concrete cover, that will also make a permeability problem, and also the chloride ion can easily penetrate because the path is less. And if the concrete cover is as per the requirement, it is not penetrate to the concrete reinforcement. Then regular maintenance, it is very much important that after doing the concrete, we all forget that is okay, concrete is 100 years, but not. You need to do the periodic maintenance. You need to check if there is any crack, if there is any spalling. So if you find any problem on the surface, immediately you have to rectify. That is one. That is the point of the remedial measure or the regular maintenance. So these are the remedial measure we can take to protect our concrete from the chloride attack. Now we need to check what is the IS code recommendation, what is the maximum uh, percentage of chloride can be permissible in the concrete or in the water. Let's see what is saying in table 7 of IS 456. What is saying, the type or use of concrete and maximum total acid soluble chloride content expressed at kg per cubic meter of concrete. So first, what is saying, concrete containing metal and steam cured at elevated temperature and pre-stressed concrete. So what is the maximum is 0.4. And then reinforcement concrete or plain concrete containing embedded steel. That means if that is steel, it is maximum 0.6. And concrete not containing embedded or metal or any material requiring protection from chloride, that is 3. So if it is not embedded steel, that is steel is reinforcement is not there, maximum is percentage is kg per cubic 3 kg per cubic meter. And metal and the steam curing on pre-stressed concrete 0.4, and reinforcement concrete or plain concrete containing embedded planer 0.6. So this table is very much important because whenever we are doing mixed design or when making test after doing the mixed design, we need to satisfy that these are the maximum amount of chloride can be present inside the concrete. But another is that we are using water into the concrete. So what is the maximum percentage is allowable as per the IS code said, it is given in table 1. So whatever the water you are using, that chloride as Cl is 2000 milligram per liter. So concrete not containing embedded steel. So it is a plain cement plain concrete 2000 milligram per liter and 500 milligram per liter for reinforced concrete work. So we are always in the concrete discussing about the RCC. So the maximum is 500 milligram per liter chloride can be present in the concrete water, whatever we are using for the concrete mixing. So these are the things about the chloride attack on concrete, and some remedial measure also I discuss, and I hope you find it useful. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload new video, you will get immediate notification. And I'm waiting for your valuable comments, so that from your valuable comment, everybody will be benefited. And if you want to know anything more about quality control and construction, please let me know. I will come with more content like this. Thank you once again for watching me.